Hello students. So today we will start with JEE Advanced 2025 Physics Paper 1 discussion, okay, which was relatively very easy in comparison to Paper 2 and comparison to JEE Advanced level, okay. So some of the questions are very easy and some of the questions have little bit of calculation and one or two questions came tough also, okay. So let's start the discussion. So first we have section 1. So in the section 1 first question, if you see this question, if I leave this spring part, okay, maybe you have read the question already, okay. So if I leave this spring part, then this is a disc which is rolling here like this, okay, motion. This question we have already solved in H.C. Verma, okay. So this question is actually of H.C. Verma. Let's see how we will do it, okay. Now what you have is, understand this thing, it's all on the inner board, that will be better option. Okay. So what we have here, we have a disc. Consider the small disc, okay, I'm not considering, okay. First let's write down the bigger one. So in the bigger one consideration, if you see, so you have the mg sin theta like this, okay, restoring. I'm taking on the center of the disc, okay, there, and there is the spring is along the disc only, right, along that path only, along that ring, right, whatever given. And so there is a kx, okay, both forces are restoring, so both forces are getting added, okay. Now when you are calculating the torque, that time actually we are calculating the torque, I am drawing the small disc with a small r radius, okay, there you calculate the torque around this point which is below, okay. Actually when it will go up, that time it will not come here, let's say the point is here, the surface is like this, okay. So at this point, when it is about this point, let's say like this, torque will come, okay. Actually both things are same, so let's draw here only, it will be easier to understand. About this point I am naming as alpha, okay, angular acceleration, rotation, okay, like this it is rotating. So on this point there are two forces, mg sin theta, okay, and kx. So what is the value of x? First of all, let's write down x. What you will say if this rotation is theta, okay, so x you can say this is L, so this you can say L theta, okay, L sin theta you will say L theta, okay. This we have done many times in the SHM, okay. So x equals to L sin theta. L, actually that is not L, that is a capital R, okay. So this is capital R into theta, okay. This is your x, r theta, okay. So there are two forces, so let's write down that thing. So torque, when you will write down about this point, okay, when you will write down the torque, okay, torque equals to, see, about this point you have two forces, mg sin theta plus, what was the other force? Other force I can say kx. So kx is what? K is k only, and x is r theta, okay, multiply by small r. Here this is small r distance, right? That's it, okay. Now one thing we missed here, this will not come r, what will come here is r minus r, okay. This is completely r, so from here to center distance is r minus small r, okay. This thing, remember this thing, that's why he missed here. He say, if you clearly see, till the end, till the base it is capital R, till the middle it is small r from the base, okay. So that's why this mistake you should not make. So here this will come r minus r into theta, okay, that's it. Now and if you see the torque, okay, actually you have to write down torque about this point, okay. I am writing about this point just for my satisfaction, later on I will replace, see how. So this torque is what? 2 by 3 m r square small r, m r square, 2 by 3 m r square, okay, about this point moment of inertia into alpha. Alpha actually angular acceleration alpha, okay, understood? Alpha. So this is what? mg sin theta plus k r minus r into theta into small r, okay. That's it. Leave this expression here only. First understand. If we see one thing, that in this, when you will displace it, okay, what will be the angular acceleration relation between, according to this point and this point? See here, this angle is theta displaced, and from this side if we see, let's name it beta, because alpha we already have, so let's name this angle as beta. Okay, this is a common displacement which we have already taken x. Okay, let's keep it x only. Now here, why I am doing this, you will understand slowly. Here if I find out the relation, so this is common side, so x I can write down what? I can say this is r minus r, okay, and this is how much? I can say this is the side of the center, from center to here, this is small r, correct? Okay, so here you can say x equals to r minus r into sine of theta is equals to here r sine beta. Okay, r sine beta. Okay, one more thing here, that if theta and beta both are small, because we are doing the SHM, so theta is, sine theta is theta and sine beta is beta, so r minus r into theta is equals to r into beta. Okay, here we will use double differentiation. Why? Because I don't want the alpha angular acceleration about this, I want the angular acceleration about this. So actually when you are writing alpha, alpha is nothing but your alpha, when you are writing alpha, your alpha is actually d2 beta by dt square. Okay, but the angular acceleration you want, that will be d2 theta by dt square. Understand? So this relation will come from here. Double differentiation of this, we got the relation. What you got? R minus r into d2 theta by dt square is equals to r into d2 beta by dt square. Okay, double differentiation, right? That's it. Leave it here only. We will use this expression. How we will use? See, here alpha is what? d2 beta by dt square. So you replace the d2 beta by d2 dt square. So what you will do? Here you have 2 by 3 mr square as it is. I will explain again, don't worry. 2 by 3 mr square here. Sorry, 3 by 2 mr square here. Okay, and alpha was what? Alpha is what? Alpha is nothing but d2 beta by dt square. Okay, but I want d2, so here I will replace r minus r by r. Okay, so this is nothing but r minus r by r into d2 theta by dt square. This is the angular acceleration actually I want. Okay, so d2 theta by dt square. This value is equal to what? mg sin theta plus k into r minus r into theta. Let's replace mg sin theta. Sin theta is theta only, right? Plus k into r minus r into theta into small r. There is one more. Okay, that's it. Now bring the theta outside and everything will be in multiplication with this acceleration equals to omega square into theta, right? So that's it. So d2 theta by dt square, if I see here, so I can say m didn't got cancel out, r square here, 1 r got cancel out, 1 r will cancel out here outside, right? So both r cancel out. 3 by 2 will go that side, 2 by 3. Okay, and r minus r is in denominator, divide. Theta will be outside. So what you have here is mg, okay, plus k into r minus r divided by capital R minus small r. Here 3 by 2, that's at 2 by 3. Okay, and then you have here theta. Correct? So this is nothing but my omega square, right? So that's it. So what he wants, he wants the omega square, omega only, right? So let's see what it is. So if I see here clearly, so let's simplify for your simplification. So omega square, let me write down, under root you can take 2 by 3, okay? And here if you divide separately, here we left the m actually, okay? M is in multiply here, okay? Now separate it both. So g by r minus r, and this side if you separate, this is plus k by m, okay? This is your omega square, correct? Here we left the m, so m came here, okay? R square got cancelled out, 1 r here, 1 r there, here outside, right? When we are writing the torque that time. So this is your omega square. So you can take the under root. So if I see the option, I have the A option as my answer. Okay, this is your first question. Got it? Next, see. So next, this question also, actually this question is in module but with a different values. Okay. So here, there are two methods to do this question. One method is by the, what we can say, vector forms. Okay. And one method is by differentiation. I will go with the differentiation method. Okay. See how. So if you see what is happening here is, there is a m mass body, right? 2m mass body coming with a u speed, let's take. Okay. 2m mass coming with u speed. Okay. And he is striking a mass small m which is at rest. Okay. And then they both, let's say from little bit gap we will give. Okay. Actually it will happen here only, but we will give a gap. Okay. I am giving a gap here. So above, which one is going? 2m mass. Okay. 2m mass is going this side, let's say with v1. Okay. And m mass went, let's say this side with v2. Okay. Let's take whatever you want to take. Okay. Above this angle is given theta. So let's take this as theta. So joining this line horizontally, this angle is theta. Fine. Let's consider this as a phi. Okay. I'm considering one angle as a phi. So this 2m mass strike this m mass and they went like this. Okay. So first of all, here in this question, elastic collision is given and he has a maximum angular deviation theta. So maximum value of theta he asked. Okay. So first of all, this is not a, like you can say, direct collision. There is a oblique collision. Okay. So that thing is clear. Okay. Fine. Now I know first equation what I can do. Conservation of angular momentum. Conservation of momentum. Sorry, not angular momentum. Momentum conservation. So initial momentum, if you see, this is at rest, right? This is at rest. And this is moving with u speed. So initial momentum is in the x direction. So final momentum should be in the x direction. There should be nothing in y direction. Write down that equation. What you will say? 2mu, this is 0, is equals to, here final momentum, what you will write down? v1 sine theta. Sorry, v1 cos theta, right? So 2m v1 cos theta by this, okay? And by this one, what you will write down? Plus m v2 cos phi. Okay, this is my first equation. Okay, because I know that what next thing I'm gonna do. So v2 you bring this side, m got cancelled out, v2 you bring this side, so v2 cos phi. Okay, next what you will write down, this thing that side, so you can say 2u minus, or 2u also keep outside, and u minus 2u minus 2v1 cos theta. Okay, this is I'm naming as equation number 1. Okay, easy question, don't worry. Every initial momentum is in this direction, right? So final momentum should be in this direction. In the vertical, there should be no momentum, right? So vertical direction, this component of the momentum upward by the 2m mass, and by the m mass downward momentum, that should be equal. So let's take this. So initial final momentum above, how much? 2m v1 cos theta, sorry, sin theta. So let's write down this one first. M v2 sin phi is equals to above momentum, which is how much? 2m v1 sin theta. Okay, understood? This is your equation number 2. So m also got cancelled out here by balancing the momentum in the vertical direction. So here v2 sin phi is equals to 2v1 sin theta. Equation number 2. Okay, understood? Till here got. Now see, one equation I wrote horizontal direction momentum, one vertical direction momentum balanced. Okay, there will be no net momentum in the vertical direction, that's why. Third equation, if you read the question properly, always all the information will be available in the question. 3 equation I have to write down. Why 3, not 4? That also I will tell. Perfectly elastic collision. So E equation you can write down. Okay, but hold on. Before that, hold on. See, how many variables we have? U is a constant, which is the initial velocity. Okay, theta, phi, v1, v2. Okay, 4 variable we have, right? But we don't need 4 equations. Okay, we need 3 equations only. Why? Because we have to maximize theta. Okay, if you have 4 equation, 4 variable, you will get the exact value of theta. Okay, we don't need exact, we want to maximize theta. So actually we need 3 equation only. Okay, now from these equations, this first and second, directly square and add, you will have cos. This phi will be eliminated from here only. In the next equation, phi will not come. I will tell how. Okay, see here. So here if I square and add both the equations, what we will have? v2 square this side. Okay, and this side if we do this thing. Okay, so what you will have? Here 4u square. Okay, from 1 square plus 2 square. Okay, 2 square. Okay, 4u square. From here you will have 2 and 2 4, 4 to 8. So minus 8 u v1 cos theta. Okay, and if you see the final thing, okay, here you will have 4 v1 square cos square theta. Here 4 v1 square sin square theta. So cos square theta plus sin square theta 1. So you will have 4 v1 square. Okay, this, let's name this equation as equation number 3. We will use it. Okay, that's it. So third equation that you are going to write, that you can write with the E also, and that you can write with the help of energy conservation also. Okay, kinetic energy is conserved because elastic collision is there, right? So energy conservation also you can do, and you can do the E also. But I will go with the energy conservation. Why? Because I have this third equation in a square, right? So kinetic energy will come in a square. I will have elimination easily. Okay, that's why. See, energy conservation, initial energy, half 2m mass is coming with u speed. So initial, this is the kinetic energy, 2m mass is coming with u speed. Final, half m mass is with v2 speed. So half m v2 square plus half 2m into v1 square. This is your kinetic energy equation. Okay, from here, half cut, 2 cut, what you have? 2u square is equals to v2 square plus 2v1 square, equation number 4. Okay, so here if you see, we don't have the phi. So actually phi we eliminated earlier only. Now if I see in equation number 3 and equation number 4, I have v1, v2 and theta. So theta I want, obviously cos theta I want, so I will not eliminate it. So if I see here, v2 is here, okay, and v2 is here, so I can eliminate the v2. From third and fourth, eliminate the v2. Third and fourth. By third and fourth, what can I do? Eliminate the v2. So v2 value from here, what you will write down? 2u square minus 2v1 square. And v2 value from here, what you will write down? 4u square minus 8u v1 cos theta. 8u v1 cos theta plus 4v1 square. Plus 4v1 square. Okay, because v1 was at multiple places, that's why I didn't eliminated v1, I eliminated the v2. Okay, everything I have a reason, proper explanation, don't worry, whatever I am doing. Cos theta is equals to what? If you see from here cos theta, so bring this term this side, positive, it will become 2u square that side, 4u square minus 2u square, right? So 2u square. Okay, and this term you take that side, so it will become 6v1 square plus 6v1 square divided by, if we see this 8u1, we will go in denominator after coming this side, so 8u v1. So 2 got eliminated. I have u square plus 3v1 square by 4u v1. Okay, this is cos theta. You want the maximum value of theta, so what should be done? Differentiation, right? So we will use the differentiation. So do the differentiation. If we do the differentiation, cos theta derivative minus sin theta. Okay, so with respect to v1 is the variable. Okay, v1 is changing here, u is a constant, so v1 is changing, this is a function in v, okay, with the cos theta. So cos theta derivative minus sin theta d theta by dv2 na v1 dv1 is equals to this side fx by gx, right? So I hope if you are a JEE Advanced student, you know the differentiation better than me, okay? But I have this thing only. So first numerator differentiation. So this will come 6v1, right? 6v1, right? Correct. And denominator differentiation, denominator as it is, 4uv1. 4uv1 minus, now numerator as it is, denominator differentiation 4u. So this will come what? U square plus 3v1 square. U square plus 3v1 square into 4u. 4u. Okay. Divided by denominator square, that is 4u v1 whole square. Okay. Now I want the maximum value of theta. So this should be 0. So this is equal to 0. So this term will also go this side 0. So this minus this is equals to 0. So this term that side both equated. So you have 6v1 into 4uv1 equal to u square plus 3v1 square into 4u. Okay. This is the term. If I see clearly here, 4u got cancelled out. Okay. And you have 6v1 square equal to u square plus 3v1 square. Okay. Bring 3v1 square that side, 3 divide under roots of v1 equal to u by root 3. Okay. Now I want the maximum value of theta first of all. So put this v1 again in the function. Function is where? Function is here, this. So put the value of v1 here. What was that? U by root 3. So put value here. So I can say cos theta equal to u square plus 3 into u square by 3 divided by, this is what, 4u into u by root 3. Okay. So if I see from here, 3 got cancelled out, u square plus u square, 2u square. So 2, 1, 2 got cancelled out, root 3 by 2. So cos theta if root 3 by 2. Okay. So theta I can say what? Pi by 3. Correct na? 60 degree only na? 60 degree or 30 degree? 30 degree na, pi by 6. Right? Cos theta equal to root 3 by 2. So theta equal to pi by 6. So pi by 6 should be the answer. So D option is your answer. Okay. Next thing. Next thing, if I see here, okay, this question is little bit complicated, but not that much. If you understand, you can answer this question little bit faster also. See how. One thing I see is, what I see here, as the given question, okay, y greater than 0 only the magnetic field is available. Okay, for y greater than 0 means this side only. If you draw in here, like this, x-axis is outside, so y is this side and z is this side. Okay, right? So magnetic field is this side, in this area only available, above, like this, going above. Okay, going above like this here. Here it is not there. Okay, so when your plate, this whatever plate is there, it is going like this, right? Magnetic field is variable with time. Okay, but not with the direction. Okay, so magnetic field here like this, sorry, this plate, whatever this square loop is there, that is square loop of wire only. So that is going this side. Okay, it will fall. After that, the plate enters to this side. It is rotating with constant omega. So after it enters this side what have? Magnetic field is 0, right? So there is no calculation of EMF, right? And after coming back here, because there is a function of B naught in cos omega t, right? So it will repeat. It is a periodic function, so it will repeat. Okay. So magnetic field will repeat. So this function will repeat after it come back. From here, it came back here, so it will repeat. So EMF will also repeat. Okay, differentiation of it is there. I will do the calculation, but first understand easy way of eliminating options. Even a average student can eliminate the option. See, as I know, the function will repeat its. Okay, so I can say here in 2 pi by omega, it should repeat, right? So 2 pi by omega, this function is not repeating, right? This function is here like this, and then after like this. Okay, so this function is not repeating. If you see clearly from 2 pi, it should come from here if it want to repeat, but it didn't came like this. So this option, D option, is rejected. Understood? D option got directly rejected. Okay, now understand. One more thing I see, what? That when it is rotating with omega t, okay, sorry, omega it is rotating, so angle is theta equal to omega t, right? Rotating with omega. So when it will complete half circle, after that this side everything is 0. As I told, from here to here whatever magnetic field is available, okay? So continuously magnetic field is changing, his area is also changing, so flux is changing. Whatever increasing, decreasing, leave it for time, okay? But magnetic flux is changing, okay? So EMF will come, okay? After coming this side, there is no EMF, right? So I can say what? That after pi by omega time, okay? 2 pi by omega is there, but after pi by omega rotation, there is no, after time pi by omega, there is no magnetic field, okay? So I can say here answer is this option directly. Understand? Confusion was here and here only. Why? Because I know that side Y negative, there is no magnetic field, right? So here he is giving that 0, but I rejected this option because of its, like it should repeat. So D option got wrong, okay? But I selected the A option because it is repeating. Here this function is from here to here it is non-zero, here to here it is non-zero, okay? So straightforward answer can come. Now see, calculation wise you can calculate, but your exam point of view there only it ended, okay? Actually by the looking also it is little bit, you can think it is little bit tough, but not actually. See how. EMF when you will write down, okay? So first of all we have to write down the flux, okay? Flux, how you will write down? Here we have B. B is what? B naught cos omega t. So we know flux is what? B dot area, right? Area vector, okay? So area vector, you can take this side also. If I draw the Z axis like this and this is your Y axis, okay? You can draw the area if it rotated. This is your plate. This is your plate. So if rotated with omega t, you can take the area this side, okay? So how much you will write down area? If this angle is omega t, this is omega t, okay? So A cos omega t this direction, A sin omega t this direction, okay? Sorry, K cap it will come na. So area vector when you will write down area, okay? So area what you will write down here, this is cos. You can take this side also. We don't go in the negative sign, okay? Negative sign you will deal by its own, okay? See, area what you will write down? Area A naught, let's take the area, complete area, A naught, and this side in the Y direction what is there? Cos, right? So cos of omega t, and this is J cap, positive, okay? But in the K cap component will come negative, okay? So K cap component negative, minus of A naught sin omega t K cap, okay? That's your area came, okay? So from here I can write down the flux, okay? So flux when you will write down, flux for B naught will come and area A naught will come. So dot product J dot K will got 0, right? And K dot K will only be 1, right? So that's why. So you will have here this term with that, and negative will be coming. So take the negative also in account. B naught A naught sin omega t cos omega t. Okay, that's it. So here what you do, instead of differentiating it like this, right? EMF is what? Minus d phi by dt. So instead of differentiating that, we will go for phi equal to divide by 2 multiply by 2 sin theta cos theta, right? So minus B naught A naught by 2 sin 2 omega t. Correct? Okay. So from here differentiate this, cos will come. So let's differentiate this also. So what we are saying is EMF is nothing but minus d phi by dt. Okay. So if you differentiate, B naught A naught is there, by 2 is there, and you will have 2 omega cos of 2 omega t. This will come differentiation. So minus d phi by dt. So this will B naught A naught omega by, so cos 2 omega t. Okay. By this you can go, that will came your EMF. You draw the graph, but graph will be till pi by, what we say, pi by omega till. Okay. Why it will be? Because in the negative Y, when it will completed half of its motion, after that magnetic field is not there in the negative side. So why what will happen with that? Okay, and here in the question only he said that you can ignore the self-inductance and the gravity. Self-inductance of the loop and the gravity you can ignore. So it is going with a constant omega. Okay, that's it. So actually question completed here only, that it will be repeating motion. So this will not come, and we know from pi by omega to 2 pi by omega it should be 0. So here it is not 0, here it is not 0. A option directly. Okay, understood? So next. So here we have fourth question, okay, which is from vernier caliper, okay, vernier scale. So here this question was little bit easier side, as I will say. See here what he is saying. Figure shown as first one is the measured value D. You have to answer configuration corresponding to measurement of D. So initially exactly aligned, okay, so we don't have to worry about this, okay. And then he is saying, so this is originally, right? So here you can count how many vernier scale division equals to your main scale division, right? So here if I see, so vernier scale division, how many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So 10 vernier scale divisions. 10 vernier scale divisions is equal to 1, 2, 3, 4, 5, 6, 7. 7 main scale division. Okay. So 7 into every main scale division, total is 1 centimeter, total is 10, right? 8, 9, 10. So every one main scale division is 1 millimeter, right? So this is 7 into 1 millimeter. So I can say 10 vernier scale division is equals to 7 into 1 millimeter. That means 7 millimeter. Okay. So means I can say 1 vernier scale division is how much? 10 that side, 0.7 millimeter. Okay. So one vernier scale division is 0.7 millimeter. Now he is asking what is this measured value. So in this measured value, when it is displaced till this point, okay. So what you have to calculate is, actually I will zoom in and I will draw it here. See how. First you have 0 here, okay. Then in the main scale if you see, here you have first millimeter, 1 millimeter, and then here somewhere your vernier scale division is coming, okay. Then which division? The second division only is matching with this vernier scale division, the main scale division, right? Second one is. So this total you want, what you want? From here till this point you want, till this point, okay. This is your D you want, okay. This I know already how much? 1 vernier scale division, how much? 0.7 mm. 0.7 mm, okay. And this I already know, 1 millimeter, right? Okay. So this I can calculate, this total is 1 millimeter, this is 0.7. So this is, let's name it X, okay. So your answer is actually 1 millimeter plus X, where X is nothing but, here total is 1 millimeter minus 0.7. So this is nothing but 1 minus 0.7 in the millimeter only, okay. So your answer is 1 and this is 0.3, so 1.3 millimeter, okay. So if the same answer you write down in centimeter, so 10 divide you can do C option, okay. So answer is C option you have, okay. Next, understood? This was easy. Like if we have vernier scales in the classroom we show, right? There we count. So he's shown by that way only. He didn't give you language. He gave you the diagram this time. Okay. Obviously he asked the question from this every year only, right? Next we have section 2. So in section 2 what we have, the first question. Okay, multiple correct. And as you know this marking scheme, how it works, right? So partial marking was there. +4 minus 2, right? +4 minus 2. See here. So in this question what he gave, he said that y greater than 0 you have a magnetic field which is above, okay, which is equals to B0. Okay, fine. And a conducting square loop of length L and mass M. Square loop of length L, mass M, resistance R is moving in XY plane. It edges parallel to XY plane. The region y greater than 0 is uniform magnetic field. So here it is not magnetic field. He is entering the magnetic field. Okay. Uniform magnetic field B0. The magnetic field is 0 everywhere else. At time t equal to 0, the loop starts to enter the magnetic field with an initial velocity V0 I cap. So initial velocity you gave him V0 I cap. Fine. You continuously not moving with V0. Okay. Sometimes it happens we move it continuous with the V naught with the help of external forces. Some of the questions are there in the notes like that. But here we are saying initial velocity we gave, then that's left. Okay. Consider the quantity K equal to this, some quantity he mentioned, in appropriate units, ignoring self-inductance. Here also self-inductance and gravity ignored as the previous question we discussed. So answer this following question. Okay. So if you read the option, okay, and you understand. So what he is saying is, B option, let's check first of all. When the complete loop is inside the region of magnetic field, then the net force acting on the loop is 0. Correct. When it completely entered the magnetic field, now magnetic field is not changing, magnetic flux is not changing with respect to time, right? If magnetic flux is not changing, then we can say that your EMF is generated is 0, current flow is 0, so force will not act. So that's it. So everything is 0, 0, right? So I can say net force acting on the loop is 0. So that's B is correct. Okay, fine. So B is my answer. Now, if you see the A option, V naught is given, the loop will stop before it enters completely inside the region of magnetic field. And C option is V naught, the loop comes at rest at T equal to this particular value. Okay. For that, see. For that, how you will calculate? Okay. First of all, let's let it enter a little bit. Okay, you draw the diagram that this x-axis is outside, so z, y. Okay, fine. Let's draw it like this only. Little bit it entered. Okay, this side is your x-axis. X-axis, this is your y-axis. Okay. Little bit it entered, and this point of time its velocity is v. Okay, let's say it entered some x amount, okay, and so it have experiencing a force backward direction. Okay, as you know, many questions you have done. Okay, we have to write down the force value. Okay, before that, let's write down the flux. Okay, and df by d phi by dt is what? EMF. So if we write down the EMF, or let's write down directly the current only. Okay, so EMF is BVL. Okay, by resistance, this is your current. EMF generated by the resistance is your current. Okay, so current you wrote. Now force, what you will write down? Force, I can say force will be in this direction, right? That will be how much? So BVL by R, this is the current, into B into L, right? Correct. That's it. B into L. That's your force. Okay. So force is equals to mass into acceleration. First, let's simplify this. B square L square V by R. Okay. This force is nothing but mass into acceleration, and this is negative. Okay. Here there is a negative. Okay, because it is opposite direction to the velocity. So velocity is there. You can put a vector, but everything is in this direction only. So that's why I am not putting the vector. Everything is this direction. Force, but we have to consider negative and positive at least, right? Everything is in this direction, but negative, positive you have to consider. Here, mass into acceleration. Acceleration is what? dv by dt. Okay. Take the mass that side. What you have? dv by dt equal to minus b square L square by m into r into v. If you see clearly, b square L square by rm, he said it is k, right? So if I say it k, so what you can say? This is nothing but minus k into v. Correct? Okay. Take this v this side, dt that side, integrate, find out the velocity at any time t. So what you will say? dv by v equal to minus k t. Okay, integration will be from when velocity is v naught at a t equal to 0. When it is just entering. At any time t, velocity is v. Okay. For what you will get? ln of v by v naught is equals to minus kt. So this is dt na. Okay. Minus kt you will get. So v is equals to nothing but v naught into e raised to power minus kt. Now see. One thing I see from here. At what t value v is getting 0? At what t value v will get 0? Infinite. At infinite time we will get 0. If you see from this, because this is exponential, right? So if I see here, he is saying at this stops and before it enters completely inside the region? It can't, because it will not stop at infinite time, it will stop. Okay, so that's why A is wrong, first of all. Okay, C is also saying come to rest. So A and C both are got rejected simply by this. When I wrote the velocity, that point only they got rejected. Now he's saying if V naught equal to 3 KL, the complete loop enters inside the region of magnetic field at a time this. Okay, he's saying if V naught equal to 3 KL, okay, velocity is given, it enters completely at this particular time. Okay, fine. So you calculated the velocity. Okay, so as we see in the diagram, when this completely enters means this x becomes L, right? So let's write down how much it is entering. Okay, that how we will write down. You can go with the here like this also, that instead of writing acceleration dv by dt, okay, you can write down it v dv by dx. Okay, from here, okay, v dv by dx, and then also v got cancelled out. By that also it can come. I can go with that also because I have calculated till here. So you can say dx by dt. Okay, dx by dt. So dt that side. So dx is equals to v naught e raised to power minus kt into dx by dt. So dt. Okay. Integrate from where to where? Let's integrate from 0 to L, where time is 0 to t. Okay. I want to find out the t only. So here integration L came, and here v naught into here. If you know that better, you are good at integration, right? Right? So let's see. So what we have, e raised to power minus kt, 0 to t. Okay. And you will have in divide. Okay. You will have in divide what? Minus k. Right? Minus k you will have in divide. Okay. So now let's solve it here only. So if you take minus k that side, or you take k only that side, because here it will be little bit different. L is equals to, or KL equals to V naught. Here when you will put t, it will come e raised to power minus kt, and when you will put 0, minus 1, right? So here I am taking the minus inside, and it will come 1 minus e raised to power minus kt. Like this it will come. Okay. V naught, how much given? V naught given 3 KL. Put the value. V naught given 3 KL. So this will become how much? 1 by 3. Okay. 1 by 3. And this side how much remaining? 1 minus e raised to power minus kt. So take this e raised to power minus kt this side. And this is 2 by 3. Okay. Take ln both sides. So you can say minus kt is equals to ln of 2 by 3. Okay. Minus that side, k that side. So you can say t is equals to 1 by k. Minus that side. So minus inside of ln, it got reverse, ln of 3 by 2. Is this given? 1 by k ln 3 by 2. So this is given. So that's why D option is also correct answer. Understood? So I hope you understood. Because my velocity came exponential, so I will reject the A and C option. And in the after completely entering, there is no net force, so that's why B got selected, and D option we derived. Okay. And those kind of integration already done in the notes part. Okay. Next, C. So here, calculation wise, you can do calculation, but actually there is no need of calculation. Why? If you clearly see here, he said correct significant figures. In the 6th question we are solving, correct significant figures, right? If I see here significant figures, so this have one only, right? So minimum significant figures we take. So if I read in this, there is only one option which have one significant figure. Okay, so D option directly take answer. Calculate, it is very easy question, notes based question, but I will take here D and I will move forward. Okay. Next, 7th question. If you see, little bit good question. Okay, here what you have, this is the source by which I can say, so this is moving like this. Okay, S1, S2, 3 string, uniform linear mass density is mu, 4 mu, 16 mu. As shown in the figure, S1, S2 are connected at the point P, S2, S3 at Q, and S3 is connected to represented. The wave from S3 is connected from wall, S3 connected from wall. This is what? Node. Okay, a wave generator O here is connected to a free end of S1. So here this is antinode actually. Okay, the wave from a generator is represented by this. So this is the wave generated. Y is equals to Y0 cos of omega t minus kx. So that's it. Okay, that is given here. Okay, we can read from here only, where Y0 omega k are constant of appropriate dimensions. Which of the following statement is correct? Okay, so if I see here, okay, mu, 4 mu, 16 mu, right? Velocities can you write down? Here first of all, source, whatever omega is there, it will be same only, frequency will be same, right? It will depend upon the source only, right? So first of all, before going in option only, I will tell what to do. Okay, see, here I know, if I go for the velocity, velocity is under root t by mu, t is same in all of them, right? So if I write down by t, so I can say here if I say velocity v, okay, in this string, so here it will be what? 1 by 2 factor will come now, so v by 2 under root 4, right? 1 by 4, so v by 2, I hope you understand. This is v by 4, okay. Now I know velocity and the k relation, right? Inversely proportional because frequency is constant. So I can say if here, if I say the k is k, which is as represented by the equation because it is in this, generated in this string only, S1 only, right? So he is saying this is k, so I can say this is 2k and this is 4k, correct? Okay, this is k, 2k, 4k in this S1, S2, S3. Okay, now come to the equation. What he is saying, when the wave reflects from P for the first time, the reflected wave is represented by this. Okay, from P point when it got reflected, okay, so what will happen? This is rarer to denser, okay, so pi phase is gonna get added, okay, and what will happen? Reflected means this side, this t and x coefficient will be same because it is going in the negative direction, okay, because this was represented by the positive direction. So I can say pi will be added and you will have your kx only, right? But here plus, okay, so this option is correct. Okay, A option is my correct answer. Okay, now next what he is saying, when the wave transmits through P for the first time, the transmitted wave is represented by this. Okay, transmitted through P, right? If I check that transmitted through P means going in the S2, right? Going in the S2 means K became 2K now, right? Going in the positive direction but became 2K, right? So what he is saying here is, here K is K only he kept. So this is wrong na, 2K it should come, okay? Next what? When the wave reflects from Q, Q point, this here, okay? Reflects means coming back, okay? For the first time the reflected wave is represented by this thing, okay? Represented, so it is in the second only na? Reflected from Q means it is here, right? Here means it should be 2K na? So this is also not correct na, here it is given K only. So this is also not correct, okay? D option, when the wave transmits through Q for the first time, transmits means going that side, okay? And here you can say this, he is saying reflected, so coming back na, so here plus should also come. So two mistakes are there, I got from the first only. Transmits, now come to D option, when the wave transmits through Q for the first time, the transmitted wave is represented by this, okay? So 4K correct, and going that side only, negative sign, so this is correct. So my answer is A and D option, okay? Answer will be A and D option, okay? I hope this is clear, okay? Next if I see here, so section 3 we came in, okay? Next we have question number 8. So what he is saying is, a person sitting inside an elevator performs a weighing machine experiment with an object of 50 kg. Suppose that the variation of height, okay, so here we have an SHM, okay, the elevator is performing in SHM, okay, time period is given, taking acceleration due to gravity 10, the maximum variation of the object weight is, so in Newton you have to answer, see how, see, so reading 1, so once he will maximum variation you find out, so maxima and minima you go, okay, so there you will see the reading, first reading will come where mg plus m a omega square will come, okay, one reading, if you talk in newtons only, right? And another R2 will come what? Mg minus ma omega square. Once it will be with supporting and once it is opposing, right? So that's what normals will come, N1 and N2, right? On the weight machine measures a normal only, he is saying normal, okay? He's not asking the mass, okay? Like kg, not asking, it's asking the Newton, right? So maximum variation is what? Subtraction of these two. So I can say answer is what? 2ma omega square. That's it. So if we see 2ma omega square, so 2m is 50, amplitude is, here if you see sine coefficient is 8, so amplitude is 8 only, you can solve. This is just moment of this what? Center of mass, oh sorry, mean position, okay? Mean position is varying. A omega square, omega is what? 2 pi by time period is 40 pi whole square, okay? From here this is 100, this is 800, this is 800, and this is 1 by 20, 400, right? So 2, okay? So this is variation is 2 Newton. So answer is 2 here. Here we can write 2, okay? So that's how answer will come 2. Very easy. These are the variation, right? Normal we have studied how it varies when acceleration upward or acceleration is downward, okay? This is the maximum acceleration upward or downward. Accordingly, you write down 2 values, okay? That's it. Next. Next, if you see, the cube of unit volume contains 35 into 10 to the power 7 photons of frequency this. If the energy of all photons is viewed as the average energy being contained in the electromagnetic wave within the same volume, then the amplitude of the magnetic field is, okay, magnetic field. So unit volume contains photons, okay. So n photons are there of h into f, okay. This energy is equals to magnetic field. So you can write down B naught square by 2 mu naught, right? Permeability, right? That's it. That's only, na? Then amplitude of magnetic field, electromagnetic wave within the same volume. Same volume. So this is volume given within same volume, average energy being viewed, unit volume. Unit volume, na? So volume 1. Okay? Unit volume, he said. That's why I was thinking like, what volume? Volume is not given. N value, put the value of N. 35 into 10 to the power 7 into H, Planck's constant 6 into 10 to the power minus 34 into F value 10 to the power 15 is equals to B naught. You have to calculate, divided by 2 into mu naught, okay. 2 into mu naught is given 4 pi into 10 to the power minus 7. Okay, pi also you can put 22 by 7. Okay, so from here B naught, let's take everything this side. So you can write down what? 35 into 2. B naught square is equals to 35 into 2 into 35. First of all, let's write down these values, okay? Not write down 2. 35 into 10 to the power 6 into what is the power? 6 into 10 to the power 7 minus 34 plus 15. 7 minus 34 plus 15 multiply by 2 into 4 pi, 8 pi. So let's keep it 2 into 4 pi. And one more power is there. This minus 7 will come this side. Minus 7. Okay. So plus 7 minus 7 cancel out. And you have B naught square. Put the pi as 22 by 7 as he said. Okay. So 22 by 7. 35 into 2, 70. Right. So by that it will get cancelled out. Let's cancel out. Okay. Hold on just. 10. So here this 7, this 2 and this 35 gave me 10. Okay. 6, 4, 22. 6 into 4 into 22. Multiply by 10 to the power. This is minus 34 plus 15. That is how much? I can say 5, 4, 19. And here plus 1, so minus 18. Okay. So this you can take under root here. Okay. So he is asking this only alpha value at 10 to the power minus 9. Okay. So alpha, if you calculate B naught, here it will come under root of 6 into 4 into 22. Calculation is little bit harder. 10 is to power minus 9, right? So this is alpha here. 2 here. This is 2. This 2, 2. Okay. So actually 4 can come outside. Under root of 11 here, 3 here, 33. Okay. So you can write down it like this: 4 into under root 11 into root 3, right? Root 3. Now root 11 and root 13 value you can put. Okay. I am not confirmed with root 11, but it is about root 11. So 3 is a 9. So 3.2 something comes. Okay. Root 3 is 1.73. Okay. So by this your answer will come alpha. Okay. You can check this root 11 value. Okay. Or you can calculate root 11 also first, then only answer will come. So by that answer comes exactly. Okay. So answer, if I tell 29, question 9. Okay. This answer is some 22.9 something. Okay. So that answer will come. Okay. You can get the answer from there. Okay. Exactly. This is the calculation. Exactly. 4 under root 33. Okay. By this whatever answer will come, that is your answer. Okay. Next. Question number 10. So here this question have what? This is from the heat transfer, right? See, two identical plates P and Q radiating as perfect black bodies are kept in vacuum at constant absolute temperature Tp and Tq, where Tp is greater. Tp is greater, so this side radiated power is going. Radiated power transferred per unit area from P to Q is W0. Okay. Radiated power he is writing per unit area. Okay. So W0 is per unit area came this only, right? So generally we write down what? dq by dt equals to radiated power is equals to E is 1 because black body, sigma A came this side, then only it became W0. Okay. Per unit area he is writing na here. So that's right. So W0 equals to sigma A gone that, E got 1, E sigma A T raised to power 4. So T P raised to power 4 minus TQ raised to power 4. This is your W0. Okay. Next, what? W0. Subsequently, two more plates identical to P and Q are adjusted plates are introduced between P and Q as shown in the figure 2. Here, two more plates came. Let's name as 1 and 2 plate. Okay. 1, 2. Assume that the heat transfer takes place only between the adjacent planes only. So adjacent. So P can transfer 1 to 1 can transfer 2 and 2 can transfer Q. If the power transferred per unit area in the direction from P to Q in steady state is Ws. Steady state. Okay. What is the meaning of steady state? We know from the heat transfer that this whatever temperature, let's name the temperature T1 of plate 1. Okay. And from the plate 2, let's name it T2. Okay. Whatever from P to 1 is getting transferred. Here if I am saying this is P, this is 1, this is 2, this is your Q. Whatever he is transferring to the 1, okay, 1 is transferring it ahead because his temperature is now T1, it became, now it is constant, okay. So whatever he is transferring it again ahead, right. So everything is Ws as he mentioned in the question, okay, Ws, okay. What is the value of Ws? Okay, so W0, let's write down here once. W0 as we said, sigma Tp na, PV is bigger, Tp to the power 4 minus Tq to the power 4. Okay, this is your W0. And if you write down Ws, okay, so Ws between the P, okay, between the P and this 1, if you write down, so what you will say, P is bigger obviously, it is going decreasing that side. So sigma into Tp raised to power 4 minus T1 raised to power 4. Okay. Then again next also will Ws. So sigma into T1 raised to power 4 minus T2 raised to power 4. Next Ws will be what? Sigma into T2 raised to power 4 minus Tq raised to power 4. Okay. So here add all three. Why add all three? So because T1 also got eliminated, T2 also got eliminated. So this will come what? 3Ws is equals to sigma into Tp raised to power 4 minus Tq raised to power 4. 3Ws. This is what? Inside W0. So what he is asking? He is asking W0 by Ws. W naught by WS. From here I can say W naught by WS. W naught by WS is nothing but 3. That's it. Okay. This is your answer of question number 10. Okay. Next. So next question we have what? A solid glass sphere of refractive index n equal to root 3 is given. Okay. So here mu equal to root 3 is given. Okay. R contain and radius R contains a spherical air cavity of radius R by 2. So here we have a air cavity of R by 2 as shown in the figure. A very thin glass layer is present at a point O. So here you can't say directly from air to air it is going. It is here we have a thin plate, glass we have, okay. Directly not going to the air, glass is there in between. Refractive index n equal to 1 of the cavity remains inside the glass sphere. An unpolarized unidirectional and monochromatic light source S emits. So here inside only we have source of light ray from a point inside the glass sphere towards the periphery of the glass sphere. If the light is reflected from point O, it's fully polarized, then angle of incidence at the inner surface of the glass sphere is theta. So here we have to find out the sine theta. Okay. So fully polarized he is talking when he is hitting O. Okay. He is at O, he is hitting at a resistor's angle, right? He is at 90 degree reflected and the transmitted, right? So by that you can answer. Okay. So actually he missed the geometrical optics and your wave optics. So what he is saying is, let's draw the diagram. So we say here in this question midpoint here, okay, like this cavity is there, fine. Here is your source, let's use, here is your source of light, connect with the center, okay. This angle is theta, this will get reflected also at theta, okay. Then after this will, if you connect, this is radius R, this is radius R, so this is angle theta, so this is also angle theta, okay. And this again will get reflected at angle theta, okay, this is also theta, got it. Now next what? From here at the center if you take, okay, if you join with the dotted line, this will come at a here like this. Okay, at this point, this is exactly below it. Okay, so here what we can say, this angle is phi. Okay, at a phi it is hitting. So this is Brevister's angle. So if we know already, here there is a glass. Okay, there is a glass of root 3, mu equal to root 3, right? Refractive index. So by that, if you remember the Brevister's angle formula, we never recommend to remember, concept you remember. So here it is coming at a phi. Okay, going at a phi and getting this side. So this angle between the reflected and transmitted is what? Refracted is what? 90 degree. So this is what? Phi obviously, and this is 90 phi. So this is 90 minus phi. Okay, so here this is 1 and here root 3, right? So I can say sine phi equal to root 3 into sine of 90 minus phi cos phi. Okay, so from here tan phi equal to root 3, phi equal to 60 degree. Okay, phi came 60. If you see clearly here, phi came 60. So this is 60, this is R by 2, this is R by 2. So this is also 60 I can say. Okay, if you connect this point here, okay, and you connect this point also here. Okay, I will not name the points, otherwise it will be very much filled. Okay, this is 60, this is 60. So because R by 2, okay, so side, alternate sides. Similarly you did here, na? Similarly here also. Okay, so now this is 60, so this is total 180. So inside one is 120, sorry, this is 60, so this is 120. Okay, this side 120. If this is 120, so what we can say, this is R by 2 and this is also R by 2. So I can say this will be equal only, 60 will be divided in equal parts, 30 degree and 30 degree. Okay, equally divided 30, 30. Okay, now if you mark this line, okay, this line, why I am going in this line I will tell, just hold on. See, here this side if you talk about, I can say here that if you draw a dotted line, okay, what you can say here, is this line, this is 60, right? So this will be how much? Here if you take theta, this is 120, right? Because this is 60, 120, okay? This angle is 120 degree. Got it? Okay. So now, okay. So what you can do here, 120, 30. Why it came 120? You can calculate by the Snell's law, okay? So this is 120, okay? Because again, this will go outside, right? So 120 this came, so this is theta. So this I know, from this yellow side I know R, right? So if I calculate this pink color line, so I will get my answer, right? So for this pink color line equation, you can say this is R by 2, this is R by 2. So R by 2 cos 30, and from this side also R by 2 cos 30. That will be that your line, okay? So that will be how much? R by 2 cos 30 into 2 times. This is R cos 30 only. So R cos 30 sin 60 root 3 by 2, right? So root 3 by 2 into R, okay? That came this line, okay? Now in this triangle, you apply the Snell's law, okay? Because this angle I know, and this angle I know, this angle I want to calculate, and this side I know, right? So for that, can I rough this? You can note down, this is very easy, right? Let me rough this part only. Okay. So here you can apply that. What you will say, sine of 120, okay, divided by sine of 120 opposite side R, and sine of here theta, you can say what? This is root 3 by 2 into R, okay? So from here sine 120, actually nothing but sine 180 minus 60, right? So this is root 3 by 2 only, okay? Sorry, sine root 3 by 2, so root 3 by 2, root 3 by 2, 3 by 2, okay? So sine theta equal to 3 by 2, sorry, how? 3 by 4 na? To 3 by 4, 3 by 2, 3 by 2, how it can be larger than 1, okay? Root 3 by 2 here, root 3 by 2 here, multiply, R got cancel out, sine theta equal to 3 by 4, okay? Means 0.75, so answer will come 0.75, 0.75, okay? That's your answer. Okay. Next. Here if you see, single slit diffraction experiment is performed to determine the slit width using the equation BD by capital D equals to M lambda, where B is the, so you don't have to go in this, what is this experiment, because he gave the equation of the experiment. Slit width capital D is shortest distance. You see here, D is the shortest distance between the slit and the screen, small d distance is given, mth diffraction maximum and the central maximum, okay? Lambda is the wavelength, capital D, small d as measured with the least count, okay? Least count is given here, 1 centimeter of the capital D. So capital D have a least count of 1 centimeter, okay? Small d have a least count of 1 millimeter, fine. The value of lambda and m are known precisely, okay? So lambda and m, lambda value is 600 nanometer and m value is 3 respectively, exactly. Absolute error in the value of b estimated using the diffraction maximum that occurs for m equal to 3 and d equal to this and capital D equal to this. B value have absolute error that you have to get, okay? Fine, okay. So what we can say from this formula, B value if you calculate, B value, if you get the, we know B, D by capital D, D by capital D equals to M lambda. From here B value I have to get M lambda capital D by small d, okay? This is the B value. So if I get the absolute error I have to get, okay? So m and lambda we know exactly, right? So for error, ln, take the ln and differentiate, okay? So ln if you take and differentiate, what you will get? Delta b by b, okay? db by b also you can write down, I will write down delta b by b. M and lambda, there is no error, right? So 0, okay? Because they are precise. So here 0, this will come 0 and plus here delta capital D by capital D, capital D plus, sorry, minus delta small d by small d. Here plus will come because we are calculating the error. Error we have always addition, right? That's it. So here delta b is equals to b. If you transfer this side, you have delta b by d plus delta d by d. Okay. So here b value, if you put if you see correctly here, so b value we can calculate also. M is how much? At m equal to 3. M equal to 3, lambda equal to, lambda value is given. Lambda is exactly known as 600 nanometer. Okay. So 600 nanometer means 600 10⁻⁻⁹ capital D, at capital D equal to 1 meter. That is also 1 meter into divided by small d. Small d is 5 millimeters, so 5 into 10⁻⁻3. Okay, millimeter, so meter. So this came in meter, but I want in the what? I don't want in meter. Okay, I want in the micrometer. Okay, to 10⁻⁻6 factor will come, that you can adjust. Okay, so that's it. And here when you will put this value you can put here b. So b value you can calculate. Okay, and delta d. Okay, the least count is given 1 centimeter. So that value, let me put, if you do some error in this, 1 centimeter. Capital D is given 1 meter. So actually you can put this above value also in meter only, 10⁻⁻2 by 1 plus delta D. Okay, so first of all, small d is how much? Small d is given 5 millimeter. Okay, 5 millimeter, and delta D least count 1 millimeter. So same unit, so I don't have to convert that unit. Okay, this b, delta b will come according to, if this value, exact value you put, this will come in meter. So convert that meter into micrometer, you will get your answer. Okay, that's how you will get it. Okay, absolute error. I hope we don't have to go in the exact answer. Okay, exactly I told this, put the value of this here, you will get in meter. Okay, so from here multiply with 10⁻⁶. Okay, then you will get your answer. So here if you multiply with 10⁻⁶, then you will get it. Okay, I hope this is clear. Next question. Here if we see, okay, so consider an electron in the n equal to 3 orbit of hydrogen like atom with atomic number Z at absolute temperature T, and neutron having thermal energy Kb, okay, into T, has the same de Broglie wavelength as that of this electron in this temperature is given as T, where H is equals to Planck constant, Kb Boltzmann constant, Mn mass of the neutron, A0 is the first Bohr radius of hydrogen atom. Alpha value he asked. Fine. So first what he said, absolute temperature T, same de Broglie wavelength. Okay, de Broglie wavelength is equal. So I know lambda equals to H by P. Okay, and that is also equals to H upon under root 2m. Kinetic energy. Kinetic energy, here he gave the energy Kb into T. So put that value Kb into T. Okay, 2m kinetic energy, write down. Kinetic energy is given as Kb into temperature. Okay, in terms of temperature it is given. And this lambda, okay, so here I can write down this, here lambda is also H by P, you multiply with R and divide with R. Okay, so sorry, lambda equals to H by P. Okay, momentum, that is mv, multiply with R, divide with R. Okay, so lambda equals to HR. Okay, divided R, I will put the value again. Okay, hold on just. MVR is what? NH upon 2 pi. NH upon 2 pi. Okay, so here H got cancelled out, lambda equals to 2 pi R by N. Okay, this is the lambda and N relation at a radius R. Okay, what is R? R I know as it is given 0.5 comes, but he said already Bohr radius is A0. Okay, so that we study in atomic structure, right? A0 into n square by z. This is the relation, n square by z. Okay, so that I can put here and I can get this lambda more simplified. Lambda equals to 2 pi, R value is A0, n square by z into n, so 1 n got. out, 1 n out, r value if you put here, and you will have by z. Okay, that's the lambda. Now he's saying this lambda and this lambda equal, so we have to get the t. Okay, fine. So what you do a square. Okay, so you square both sides and put the value now, square and then equate. Lambda is square, here lambda is square, because I want a t. So h square here 2m kb into t, and this side if you do square, 4 pi square a naught square n square by z square. Okay, okay, here we have everything. A naught square alpha square a naught mass. Okay, fine, z square is there. Fine. Okay. Now t, I want t this side, this things, this in numerator, this in denominator. Okay, so t value will come how much? Z square h square divided by here 4 into 2 8, and n 8 n square, and here m kb pi square a naught square. Okay, everything okay? M kb pi square, m here, kb here, pi square here, a naught square, alpha is asking. Okay, so alpha is nothing but your 8 n square. N square he gave, n value how much? He said for n equal to 3, n equal to 3 in first line. Okay, so put the value of 3, 8 into 3 square 9. Okay, so alpha is how much? 9 8 is 72. So 72 is your final answer. 72. Okay, next question. Next, section 4. So in section 4, let's go for the first question. So we have some electric fields. Okay, fine. Dipole only, easy, right? So this dark green will work. So here, if at this point, x point only is asking distance between two r, so r. Okay, fine. From x point, this both are r distance, right? So downward, I can say how much it will be. By this dipole, it will be downward kp by r cube, and by this dipole also downward kp by r cube. So downward actually 2 kp by r cube in the p option. Okay, so k value 4 pi epsilon naught, so 2 will come downward, j minus j cap. So 2 p2 2 matched. Okay, p2. Now obviously you have to go with the option. Okay, so that you can do more faster. So p2 means b and a option rejected. P2. Now if I see here, there is no point of checking with q, right? So q is because 1 only, and s is 5 only, so I can't check with. I have to check the r. Okay, so by r only I can decide. So r, let's check the r. Okay, so r, if I see here, so downward it will be how much? Kp by r cube. Okay, by this dipole, this side dipole, left side, and by right side dipole, this will be this side, 2 kp by r cube. Okay, so in the I cap twice, and in j cap downward minus j cap, right? So 2 I cap and minus j cap. 4 k value 4 pi epsilon naught, r cube outside, p outside. So fourth option, r4. Okay, so r4. So R4 C option. So answer we got C option. Okay, that's how. Understood? Simple dipole, easiest question possible of this whole paper. Next. Alternating current question. So V is given here to you. Fine. So first we check with the resistance thing only. So by that, if we go here, you can say current will be what? In the P part only, na? P. In the P only. If you say the current, so that will be voltage. Voltage is how much? 300 sine 400. 300 sine 400 T by resistance. Resistance value in P is given 30, right? So there is only resistance only. So this will be 10 sine 400 T. So if you see the amplitude is 10, right? Whatever the equation is coming, by amplitude is 10 and sinusoidal curve. So amplitude 10, sinusoidal curve, this is only given, right? So third option. So P is matched with third. Okay, so P third. Here P third. P third, if I see, P third is in A option and C option. So B and D got rejected. Okay.
Now if I see in this, here also same situation is becoming as previous question. A we checked, so PS3 we checked, right? So P3 we checked, so A or C option is selected. But if I check the R, it will be same, S it will be same 1 1. So by R and S I can't verify it, okay? I have to go with the Q, okay? That's what JEE Advanced will play with you, okay? So you have to go with the Q verification, okay? So let's verify the Q. If you say here Q, okay? P is 3 as we said. Q, if you go, there is a resistance and there is an inductor. Okay, so we will go with the omega L. X for the calculation of XL, omega into L. Omega is how much? 400. Okay, L is how much? 100 into 10 is to power minus 3. Okay, so this will be how much? 40 ohm. Okay, 40 ohm. So get it. So what you will get the equation? If I see the equation of current, I will get some 300 as it is, 300 sine of 400t plus phi I will get, that I will write down phi if needed. Denominator you have under root of z, right? Z na only na, z what you will write down here, 50 na, because one is 40, one is 30, right? Here this is 30, this will become 40, right? So 30, 40 under root, right? Under root of 30 square plus 40 square, that is 50, okay? So by that 50 will come. So if I see here, I is equals to, this is 50, 6 sine 400t plus phi, okay? So with the amplitude 6, sinusoidal curve with the amplitude 6, here I am able to see this one, second option, right? So Q have a second option possible, okay? Or Q have a second option possible, or Q have a, here this fifth option also. Q have what? See here, Q have second option possible or Q have fifth option possible, okay? I can calculate very easily, okay, phi, okay? But still I will not go with that. See how? 2 and 5 possible na? So if you already rejected B and C, so A and C if you see, Q you have 5 and 4 is competition. Q is not even, 2 is not even in competition, right? So 5 is in competition, A option directly answer. Okay, still if you want to calculate, so you can say this side 40, right, and this side 30, so this will come how much? 53 degree, okay? So this is behind, so minus 53, okay? So 5 will come minus 53, so minus 53 means negative, from at t equal to 0, negative value it will start, so negative means this fifth option only, okay? So Q will go with the fifth, that's why. Otherwise you can go with that amplitude is 6 in this option and amplitude is 6 in this option, right? Here 5 is here, 6 is here in the second option and the fifth option. So second and fifth, but my options are A and C only, right? So A and C, there only I can decide that 6 is coming in the, so 2 is not even in competition according to options. So 5 is only in competition, so A option ticked, okay? Okay, that's it. 15th done. 16th if you see, so here questions, you don't have to go with complete question, go with whatever you know. So energy of characteristics X-ray, right? That I know that it is proportional to energy is asking na energy, okay? So that I know Z minus 1, right? Okay, by the Mosley's law we know that that is Z minus 1 ka whole square, okay? I don't have correct pronunciation, okay? I don't know why I am not able to pronounce that correctly. Okay, so Z minus 1 I know. So first Q1 competition is not there. See, if I answer the Q1, there is no competition. Okay. And second, if you want to answer, you can answer the electrostatic part of nuclear binding energy for stable nuclei with mass number is range. Nuclear binding energy, you have to make the pairs, okay? So there are Z, right? So how many pairs? Z into Z minus 1. So R option, okay? 2 is matching with R, so R2 will go here also, right? So this only coming. So this will come C option, okay? Directly go with what you know, that's it. You have to save maximum amount of time, but here in this question also there was a trick, as I told, okay? There is little bit time you can save, and obviously you have to go in the match the column with the options. Okay, that's it. I hope this is clear. So this paper was very like you can say according to JEE Advanced level, easier mode. Okay, according to if you go JEE Advanced, and paper 2 will be little bit tougher. Okay, that we will also discuss. So for this paper till this only. Thank you.